Okay, so my name's Carl Robinson. I am talking today about regression and why it is better to explain regression using x subscript 1, x subscript 2 instead of an xy axis. So I'll show you the xy axis like here is an xy axis, and as you can see, like, it is good an xy axis. And then regression, you know, just a quick recap of regression. It's basically like plotting data, then like say like we had just like data we collected and it was something like this. Regression takes like the average distance between the points and it finds the line which the points are most the line which the points are most average meeting together, like the average closest average line which will suit the points. So that would give us like some sort of, like, this is supposed to be a straight line. I just didn't draw it too good, but like to fit a straight line you get something like this. And then but forget all that. That is not regression. Regression is not about fitting a straight line to points. It is something very similar to that, but it's not that. So like the problem is fitting a straight line to points means that it's all about, like, it's just all about fitting the line. But you actually have to put your mind a step beyond that to think, how is what's on the axes colliding with each other to create a merging point, like to create a like, I don't know, I wouldn't use like how is this variable and this variable influencing each other? So it's not the points that we're looking at. You have to think in terms of influences, in terms of rates, not the point, which is something exact. But regression is not about exact points. It's about the what's influencing the exact points. So that is why I do not like the use of an x and y axis, because x is an independent variable, y is a dependent variable, but regression is about how two variables influence each other, which there are cases which an x and y would be suitable when you are measuring how much a independent variable is influencing a dependent variable. I didn't explain that too well because I actually lost visualization in my head there, and I know if I'm not visualizing it as I'm saying it, it wouldn't make sense. You wouldn't be able to visualize it either. But basically that's why I'm doing this lecture. I want to visualize it as I say it, which I do lose the visualization sometimes, so apologies if it gets vague. That's probably because I've stopped bothering to visualize it and I've just raced along and said it in like a faster way than I should have. But basically, like, if I use x subscript 1, x subscript 2 for a regression, then they're both x variables. They are both independent variables. So then I'll draw the same sort of thing, but I'll explain it a bit better. So, see, now you can think in terms of influence. Like, this is the x subscript 1 and x subscript 2. When their influences are merging together, the regression line is where you take influence of x subscript 1, influence of x subscript 2, and you find, and you mix two. It's like you're taking x subscript 1 influence, mix it in, x subscript 2 influence, mix it in, mix them together, and the mixing together is the regression. So basically, regression is mixing together two or more. I won't go into or more. Well, let's just put a straight line regression is just mixing together two influences, basically, and then you can have more than two influences. You can actually have like infinite amount of influences. So yeah, but that's why I use x subscript 1, x subscript 2. So it's actually the influences. So you can easily tell now, you know, that which variable, which independent variable has the strongest influence on this line in terms of like what's pushing it the most. Will be x2 in this case, because you know the gradient of the line is steep like this, because x2 is pushing upwards more so than x1 is pushing the line across. And now I'll show you, maybe let's throw in, I'll show you a way you could throw in maybe, yeah, like I'll show in, like, this is a quick way for a straight line regression. You could also plot like a second one. It'll be good. I don't have much other colors, but I'll just use a pen. Apologies if it's unclear. But let's say we're plotting x1 against x3. Say like same independent variable x1, and then we added in a new, these are two separate graphs but just shown on the same plot. So like this would mean that x3's influence is even weaker than x1's influence. So that means if x2 has the same constant influence, then if we're to put, I'll actually keep x2 on this axis, and I'll move x3 onto here, so then you can see the same x2 pushing. So x2 against x3, I'll plot this, and if I've explained it enough already, this is a good test to see if I explained it myself, because you should be able to predict if I have x2 here and x3 on this axis, and x3's influence is even weaker than x1's influence, then you should be able to guess what this line is going to look like. I'll put x3 on so you know where I'm going to put x3 for this line, and then yeah, x2. So I haven't drawn the line yet, but as you can see, if x2 is here, and we know x2's influence is really powerful, and then x3 is up here, and we know x3's influence is even weaker than x1's. And then we would have a line like this, because if x2 has the same influence it did before when we plotted it against x1, and then plotting it against x3, which has an even weaker influence, that means that x2 in this red line scenario pushing really high and making this gradient really steep, because its influence is just so much greater than x3's influence. And then once you get your mind around yeah, thinking of regression in terms of the factors or variables on the sides of the axis being influences rather than just something which you plot, you can also easily understand the concept of logarithms or something like that, because a logarithmic curve would basically just mean that it's a moving influence. Like, I'll show you, yeah, like it won't be a straight line. Yeah, so oh wait, I drew that one wrong already. I am very bad at drawing graphs. Well, not bad, like I'm really good at drawing graphs, but then the smaller details, like I'll like put the x-axis and the y-axis the wrong way around, just because I'm so into like the thought behind it that I forget like to like, that's why my writing's so messy, because I'm so into the thought. I forget to like, I stop caring about what it actually looks like. I just want to think of the thought behind it. And then, so like, I'll do a logarithmic with a x2 and an x1. Yeah, and like, I didn't show you this before, but like the axis is like, even though it is better actually, it's actually better to have like your smallest, like an x is always going across, y is going up. But when you're talking in terms of like they're both x variables, you can have like x2 on the bottom axis, or or you can have x2 on this axis. Like, it's just like, axis is just like a good tool. Like, it's not the actual thought. Like, it's like, it doesn't actually need, like, there's actually like, I can actually explain this using bubble graphs instead of like, I can explain this using bubble graphs moving in real time, but except I'm bad at like, I'm not good enough at computers to program a real-time bubble graph, which would be something which would be, if I was better at computers, a real-time bubble graph would be a really cool way of showing that you don't always have to use axes